Okay, so here we are again, and on your left what you're seeing is the standard workhorse. Now, this guy works hard in the Histopathology Techniques museum. I just said museum, that's quite funny. I hope you picked up on that. In the Histopathology Techniques laboratory. I think sometimes it can feel like a museum with all the specimens. So this is called a Tissue Tech VIP, and the nifty thing about this is it can be set up to your cell phone. So, if you're the medical laboratory scientist on duty and this machine is on during the night and it incurs a error, that error is reported to your cell phone immediately, so you can come in and just correct it. You can imagine, so this is the basket. So with a basket full of patient samples that are potentially in a lot of chemicals, ethanol and xylene, if something breaks down, those samples will not be able to be processed continuing the process the next day. And that's a problem, right? So it's important that you be notified immediately, so it has a cell connection to the medical laboratory scientist on call. So we just call this a little basket. And those holes are very important because they're going to allow all the chemicals that need to do the job, the dehydration, the clearing, and the impregnation, to enter. This is just the control panel, so that's the name up there. This is your control panel. And that's where you set your schedules. Now, small biopsy, and we can use the BX abbreviation for biopsies, require much, need less time in the tissue processor, because they're smaller. They don't need to be, manhandled, so to speak. They don't need long time dehydrating, long time clearing. So there's often a button here that you can just push and put on, which will allow it to do a rapid cycle, and that can be run during the day. During working hours. Sometimes even less. So let's make it 2 to 5 hours. And I will check up on that and stand corrected. But if we take a small biopsy and we put it through a long processing schedule, we run the risk of changing its morphology. And the big risk with a small biopsy exposed to a long processing schedule, commonly cited artifactual changes are over dehydration, and you end up with a shrunken and brittle specimen. Okay, let's move my face out the way there. It's to shrinkage. Oh, guys, you're going to learn to read this crab writing, right? Shrinkage, and that's a B. Wow. And where you'll experience this, where you'll feel it, at two places where you will pick up on it first, is either at the next phase, which is embedding. And if you miss it at embedding, you'll pick up on it definitely at the microterm. Why I'm bringing this up now is I just want to show you that everything is connected. Because we talk about a link or a process in the histology lab, your tissue is on a conveyor belt that is undergoing a process of exposure to various mechanical and chemical, so physicochemical changes. And if something goes wrong, and the pathologist gives you a ring in the laboratory, he'll say, listen, this tissue doesn't look right, guys. You need to be able to Look at that histology preparation under the microscope and determine from what you're seeing what could be wrong. And where did it happen? Where along the way did it happen? Was it, here, it's a, look at that one, isn't it awesome? Was it at registration? At cut up? Was it at processing? Was it at embedding? Was it at microtomy? Floating out, which is really part of microtomy. Staining. Sometimes problems even occur at cover slipping. So I hope you got that. That is just the worst handwriting I've ever seen. So quick summary: registration, cut up, processing, embedding, microtomy, floating out, staining, and cover slipping. And hopefully by the end of all these videos you'll have a cohesive whole, or as they say, a gestalt on the entire process. So let's just delete these and create. This is what I call an action shot. And the action shot is showing you a hand and the receptacle lid to this container here. There's a hole here, a gap, and inside there is a space. It's pretty much showing you the dimensions. It's not very big. It's that size. And inside there you're going to place this, which is the cassette, the basket, and inside the basket you're going to load all those tiny cassettes that you've got your tissue in. I would say you can load about 150 in one of these, so you can load about 300 in here, and they remain stationary inside there. So this is not the carousel type, but this is a modular unit or stationary unit tissue processor. And if you cast your eye over this side, you'll see they are plastic containers, and they have the tissue processing reagents inside. Well, they contain those tissue processing reagents. That's your graded alcohols, and let's write it here. See if the pen's not graded. Alcohols, so that's your 65 and up to absolute, and your xylene, and the machine is computerized, obviously, as you can see, and it has a pump and a vacuum even to facilitate or enhance the impregnation. So they pressurize it. It's a vacuum, and they can do that because this is a sealed unit. But the point I'm making is that it'll pump the reagent into this space when it's needed. So after an hour of ethanol, it pumps it out again, puts in maybe 65%, it pumps it out, and then it'll pump in the 70%, leaves it in for an hour, pumps it out, pumps in the 96%, pumps it out, and so it's an exchange, continuous exchange, and even the wax. So it's stationary, and it just runs for that allotted time. Okay, so this is the tissue processor unit. It works really, really hard, and it's a vital component in the histology preparation laboratory or in the lab.